Let's start with our next question, electricity. So basically, electricity is a very simple question, but we need to be careful about the variables and the apparatus especially. So let's see. Diagram 4.1 shows a wiring system in a kitchen. Each appliance is connected to the main fuse box with suitable fuse and different thicknesses of wire to prevent overload current occur. The lengths of the wires are the same. So in the question itself is already given the variables, especially the thicknesses is the MV and the length is CV, length of wire CV. But we can put other CV as well. So let's see here, if we use thick wire, we have to use a bigger current fuse, bigger current limit fuse. The next thickness is 30 ampere fuse, and the thin wire is the least current fuse. Okay, so let's state it again, the MV based on the pictures. So the MV is thickness of wire, or we can say diameter of wire, or cross-sectional area, cross-sectional area of wire. So all of these three are acceptable. Make sure that you put cross-sectional area in full, not just cross-sectional or cross area, or just area. It's not also not acceptable. So the RV, like usual, we need to measure the resistance. Okay. So let's answer the first two questions. The resistance depends on the diameter of wire. Hypothesis, the larger the diameter of wire, the lower the resistance. Okay, before we answer the aim of the experiment, let's see what's the question given us on the apparatus. So with the use of apparatus such as constant wire, voltmeter, and other apparatus, so at least functional. Describe an experiment to investigate the hypothesis. So we given constant wire and voltmeter. So we need to actually know at least, but even though if we already added enough, if the apparatus setup is not functional, so it's also wrong here. So make sure that you know which apparatus is functional, is vital for the experiment. Okay, let's answer the aim. To investigate the relationship between the diameter of wire and resistance. Okay, and we make sure that you write in full. Diameter of constant wire, so we can specify here constant wire, because we usually use constant wire in the lab. RV resistance. CV, either you want to put length of wire, or this is the most standard one, current. We constant the current for all electricity related experiment, especially factors of resistance. We have to make the current constant. If the experiment is Ohm's law, then the current is actually the MV. RV is the potential difference, whereas the CV is resistance. Okay, that's for Ohm's law. So let's list the apparatus. First, we have to list the two apparatus given, which is constant wire. Yes, constant wire, constant wire with different diameters. So it's better that you list all the diameters in terms of SWG. So SWG20, SWG30, SWG40, SWG50. So basically, the higher the number of SWG, the thinner the wire, and vice versa. So voltmeter, don't forget about that. And then ammeter, rheostat, dry cells, connecting wires, and switch. Okay, so let's draw the circuit. So it's always, the diagram is always like this. Make sure that you draw it properly using ruler. Don't need to label other than the constant wire, but if you want to label all, it's no problem here. Constant wire. Definitely you can label it. First, for the experimental procedure, set up the apparatus or circuit as shown on diagram. Number two, we have to control the variable. Connect SWG20 constant wire to the circuit. Number three, we have to make functional, the apparatus functional before we record the responding variable. So switch on or close the switch. So I like to close the switch. Close the switch and adjust the rheostat to I equal to 0.5 ampere. So the value of 0.5 can also be 1.0 ampere. But that, you don't need to make it higher than that. 0.5 and 1, between 0.5 and 1 is very good enough. And then we can start to record the reading of voltmeter as potential difference, or record the potential difference by using voltmeter, also correct. And then, but this is not the responding variable exactly. So we have the responding variable is actually resistance. So we have to calculate it manually. So the final sentence here before repeat, we have to calculate resistance by using formula. Resistance equal to potential difference divided by current. Okay, that is the true responding variable. And finally, we have to repeat experiment by using SWG 30, SWG 40, SWG 50, and SWG 60 of constant. Oh, yeah. Okay. So tabulation of data, we have a table here. Make sure that you make it using ruler and neatly. So SWG, potential difference, you have to write it in full. Resistance. But you can also write in a symbol, a very well-known symbol. For example, the potential difference is also a V symbol, but you have to define it in the procedure. Also, resistance, we can replace it with BR, and then slash O. So we have 5 data. The data itself also can be ambiguous. Doesn't need to be specified with SWG. You can write it as A, B, C, D, E, or X, Y, Z, W, Q, or something like that. 40, 50, and 60. Okay. So the analysis of data, make sure that you draw the axis using ruler. And then this is the SWG, or you can say it's diameter. Okay. Okay, that's all for today. Hopefully that you're able to answer the question correctly with the correct technique. I think the electricity always gonna be the same kind of way of answering it. So the same apparatus arrangement, the same list of apparatus and materials, but what you need to change is the manipulated variable. If the MV is the length of wire, then you have to use a constant wire with a different length. And then also the variables as strong. So I think you can answer this question correctly if you have enough practice, if your memory is good. So make sure that you practice a lot of questions relating to electricity and electromagnetism for full 5 experiment. So I think that's all for today. Hopefully to see you again soon. Thank you.